In this video, we present our work, What Did the Robot Do in My Absence? Video Foundation Models to Enhance Intermittent Supervision. We develop a framework that provides a user with either generic or query-driven summaries of robot videos in the following output modalities: a short summary video, dynamic summarization, a storyboard of key images, static summarization, and a language-based text summary. To the best of our knowledge, this is the first work which incorporates video foundation models in a zero-shot setting to generate summary communication in multiple natural modalities from a robot to a human for intermittent supervision. In the proposed architecture, there are four main steps: pre-processing, embedding, relevance generation, and selection. For detailed descriptions of each step, please refer to the paper or our project page. We designed a user study to evaluate whether users could benefit from such a summarization framework. We consider a search and rescue mission undertaken by a fleet of robots in a complex underground environment consisting of tunnels and caves where they explore the previously unknown environment, searching for specific objects. After extended autonomous exploration, a human operator is asked to identify key objects and events encountered by the robots during the operator's absence by either reviewing the raw video data or summaries of the data generated by the proposed framework. The user study is developed as a mixed model design. A total of 30 participants were recruited for the study. They were randomly assigned to either the generic summarization pipeline G or the query-driven summarization pipeline Q. Both groups experienced 4 intermittent supervision tasks: control, video, storyboard, and text, where the order of tasks is randomized. Control consists of only the raw video without any AI-generated summaries, and other tasks have the AI-generated summary in the corresponding modality accompanied by the raw video. Each task was to answer a set of 6 questions based on front egocentric video feed of the robots. Between tasks, the video and the set of questions changed to prevent potential influence of earlier tasks on later ones by preventing users from memorizing and anticipating similar questions. For a given task, users got the same video and set of questions under G and Q conditions. The questions were designed with varying difficulty to assess the user's ability to identify relevant information. These questions are broken down into 2 types of questions: object-related and event-related, referred as subtasks. Here we first demonstrate the generic user study interface. Participants are given instructions on how to complete the study and shows what the objects look like. The study starts with a pre-experiment to understand their familiarity to robotics, the given task, and AI-generated video summaries. The tasks are then introduced in random order. In this demo, control comes first. Users can play it at different speeds to find answers to the questions on the right. Then the user rates their experience. Next, we have the generic summary video, which is less than 6 minutes long as opposed to the original footage, which is almost 40 minutes. Participants are free to play or ignore the raw video at the bottom left. Then the generic summary storyboard, where the users are shown 24 key images in a scrollable manner. Finally, the generic text task with a generic description of the raw footage. Finally, participants give their preference on summary type and modality. The 4 tasks have 4 different videos and different questions. Now we demonstrate the query user study interface. We have excluded similar pages to the generic pipeline like the instruction page and the familiarity page. First, we have the query summary video task. Same as before, we have the original long footage at the bottom left. Here the user inputs their query to get the answer for the questions in the query box. The framework produces a summary video which is about 48 seconds long, which the user can use to answer the questions. Next, we have the query storyboard task. Similarly, the user inputs their query to generate 4 key frames that best matches the query. Finally, we show the query text task, where the user gets the reply in text format like a chatbot to help answer the question. The user study is run to validate 2 hypotheses. H1, distilling data improves accuracy and time for retrieving relevant information as opposed to providing raw data. H2, the magnitude of the improvement in accuracy and time depends on the summary type and modality. Some notable findings are: query-based summaries significantly improve user score compared to raw long videos or generic summaries. However, this comes at the cost of efficiency. With storyboards, accuracy and efficiency are both improved. With video and text, there is a trade-off between accuracy and efficiency. More detailed analysis can be found in the paper. Our study serves as the foundation for future work to develop advanced VIFMs that can dynamically adjust to different interaction contexts, understanding linguistic subtleties and implicit knowledge structures of users, and generate contextually relevant summaries. Please visit our project page for more details. Thank you.